This is 5-5, solving linear inequalities. So this is just like graphing an equation. There's a couple little differences. So one of them is that there's not an equal sign. That's what makes it a linear inequality, right here. And a solution of inequality is any ordered pair that makes the inequality true. So instead of there being one solution or infinitely many solutions, it's sort of like a group of solutions. And they're shown using a shaded area of the graph. So we're going to work on how to graph the line like we did with an equation, whether it be dotted or solid, and how to shade the graph as well. So whenever we have, when we're drawing the line on the graph, it'll be a solid line like this if it's greater than or equal to or less than or equal to. If we don't have the equal to bar there, then it'll be a dotted line. So that would be a less than or a greater than. No equal to is a dotted line. And we call this other one a solid line. And that's shown in this large display of information here. The first thing you might be asked to do is to tell whether an ordered pair is a solution of the inequality. So we're wondering, is this ordered pair the solution to this inequality? So remember that ordered pair is just an x and a y. So what it's asking us to do is just place the y and place the x, the 4. And we need to see if this is true. Is 5 less than 5? No. So it's not the solution. Same thing for the next one. We're going to plug 1 into the x and then 1 in for the y. So 1 is greater than 1 minus 7. 1 is greater than -6. Well, this one's true. So it's yes, it is a solution. Tell whether the ordered pair is a solution. Yes, it is. Here are our steps for graphing linear inequalities. So basically the first thing is to isolate y, just like you would if you were going to graph an equation, because we need the m and the b so that we can use m and b to graph. And then step 2 is going to be to actually graph it with that m and b, and be sure to use a solid line or a dashed or dotted line. And then we're going to be shading which area is true. And so let me show you what that's going to look like in the first example here. So graph the solutions of each linear inequality. So the y is already isolated. Okay. Next we're going to graph the b and m. I did it that way because we begin with the b, so it's at 4 on the y-axis like I graphed here, and my slope is 3 over 1, so rise 1, 2, 3 over 1. I can't go up 3 and over 1 again, so I can follow my path. I went down 3 and to the left 1, so down 3 to the left 1, and I could continue that. And I need to see if it's solid or dotted. So with a dotted line in this case, and it's dotted because there's no equal to. So it's going to be a dotted line. Like so, with my arrows on either side. And step 3 is the shading. The shading part confuses people. So what we're trying to do is we're trying to see, are we going to shade this side, or are we going to shade this red side? I'm going to leave them both shaded for a second. Notice that the 0, 0 point, the origin, falls in the red. You can pick whatever point you want. I'm going to test 0, 0. So I'm going to test a point. I'm going to plug in 0, 0 into the equation up above. So 0 is less than 3 times 0 plus 4. 0 is less than 4. Is that true? Yes. So we keep that side shaded. Shade the true side. Since 0, 0 is a solution, it told me that we're going to keep that whole side. Oops, I just got rid of the line. We're going to keep that whole side shaded. So I can't have any blue shading left here. Let me put back my line that I lost. It was up 3 over 1. Put back my red dots. Okay, and so This includes every point in this shaded area below the line. It kind of makes sense because it was less than this equation. Y was less than. So everyone below this line is a true solution. So there are a lot of solutions here. 0, 0 happened to work. I can tell you right now that like 2, 1 would work. Notice it's still in the red. So that would be a solution. Negative 3, 2, negative 3, sorry, 2, negative 3 would be a solution. Something on this side. Negative 2, negative 5 is a solution. All of these are solutions to that inequality. Here's another one. The first thing we need to do is isolate y. So I'm going to subtract 3x to get that to the other side. And I have 2y is greater than or equal to negative 3x and a positive 6. Divide everything by 2. Y is greater than or equal. Negative 3 over 2 is simplified already, and 6 over 2 becomes 3. So now I have my equation. I also know this is going to be solid. So my m is negative 3 over 2. My b is 3. So I'm going to begin at 3. And I'm going to rise negative 3. So down 3 to the right 2. Just double check and make sure that your inequality is going to be a negative slope, because that's what we should have. Solid line because it's equal to. And now again I need to shade, so I'm going to test a point. I just like to test 0, 0. So it's not on the line, so we're able to test it. So 0, 0. If I plug 0 into the original equation, it will be 3 times 0 plus 2 times 0 is greater than or equal to 6. Well, that's 0 and that's 0. So 0 is greater than or equal to 6. That's false. 0, 0 is false. So I cannot shade where 0, 0 is right now. I need to shade the other side of the line. So this is like my boundary. I'll go from one end right to the other so that you can see. This is dividing this space. I just made the line longer. And so all of these are my solutions, because where the 0, 0 fell, anything in this would come out false. I tested that and 0, 0 was false. Okay, this is kind of thinking a little bit differently, but I sort of like these. So we need to write our inequality. So I know we're going to need a y and an x, and I'm going to need my m from the graph, and I'm going to need my b from the graph. I need to see if it's going to be a plus or a minus right there. I'm going to need to see which symbol it is. One of these symbols. It's kind of what's happening here. So the first thing I'm going to start with is, what is my slope? Well, my slope is from one point to another perfect point is going to be down 1 over 3. Down 1 over 3. So negative 1 over 3. My b is hitting at 2 on the y-axis. So I have y, negative 1/3 x, plus 2. And now I need to decide the symbol. Notice that it's dotted. So it's one of these bottom two choices. And I believe it's less than because it's below the line. So let me just do a quick test of that point 0, 0. Is 0 less than negative 1/3 times 0 is 0 plus 2? Is 0 less than 2? Yes, it is, so I picked correctly. So you can guess, and then you can also check. Okay, next one. So my m for this one, let's find some good points here. Ones that actually hit. So that'll be up 1, 2, 3, 4, 5 over 1. So the slope is 5 over 1. The b is crossing at negative 2. So I now have y, 5x, negative 2, minus 2 instead of plus negative 2. And now I need to see, is it less than or greater than? It's to the left of the line, but it's kind of above the line. So I really don't know on this one. I know it's equal to. It's either this or this. I need to decide which one. So let's say I take a guess that it's going to be less than or equal to 5 times 0. I'm testing 0, 0. Is 0 less than or equal to negative 2? No. So I picked the wrong symbol. It's not less than or equal to. It's greater than or equal to. My last one is an undefined line. Remember, undefined lines have an equation of x equals. So this is going to be like that. It's going to be x and the number, which is negative 2. And then I need to decide if it's greater than or less than. So, or it's equal to, because it's a solid line. So greater than or equal to or less than or equal to. I'm going to guess greater than or equal to at first. So I'm going to test 0, 0 like that. So 0 is greater than or equal to -2, and that's correct. So my original thought was correct on this one.